Hello, everybody. Good morning. Can you guys hear me okay? Can you get my accent? Perfect, perfect. So thank you for having me here today. My name is Luis Girigay, and when I got invited to do this presentation, I had the option to go and talk about AI. I had the option to talk about maybe some high-level inspirational talk, but I said, everybody in this room is probably a technical person. Everybody in this room, they will probably hear a lot about Gen AI and other technologies that, plenty of sessions during the day. So I decided that, you know what? Let me talk about something that we don't talk enough. So let me ask a couple of questions. How many of you are developers? Okay, quite a few. What about cloud architects? Perfect, perfect. How many of you are responsible for any type of technology or production system? Like you are in charge of the website or email or something? Okay, quite a few, perfect. So how many of you, for this one, you don't have to raise your hand. I think that you don't want to. How many of you have moved something into production, and what you did before moving that system into production was send an email to your team like, hey, everybody, at 9:05 a.m., go to this website and do refresh, right? So I see some people laughing, so I know you are doing it. That's why I ask people to not raise their hand. So that's what we're going to be talking about today. I'm pretty sure you are familiar with this stadium, Wakanda Stadium. Apologies if I didn't get that pronunciation right. When you are an architect in the construction industry, or when you are a civil engineer, when you are about to build something like this, there are a lot of standards and best practices and documentation that tells you you have to use this concrete. You have to use this type of supporting column. You have to do this particular diameter in the water pipes, right? So all this documentation, all these standards and international standards make building stadiums, infrastructures, something like this. I'm not going to say easy because otherwise everybody would be doing it, but it's tested, right? So on a stadium like this, which is almost 40,000 people, when they build it, they had to make sure that it was going to be able to support not only the 33,000 people, but also the machinery, the infrastructure, the chairs, the vendors, everything. And this is why I wanted to talk about this, not building a stadium, but for you guys as developers and cloud architects, how to build efficient and reliable architectures. Reliability, efficiency, and resiliency are going to be the three topics we're going to be focusing on today. When I started doing public speaking and talking to audiences about 20 plus years ago, there was this particular quote from an American poet that said, people will forget what I said or what I did, but they will not forget how I made them feel. So it's okay if by the end of the day today, you don't remember who I was. Who was that guy from Miami, like talking about whatever? That's okay. But if there is one thing I want you guys to go back home tonight with is I can build infrastructures, I can build applications as strong, as powerful as the Wakanda Stadium in Mumbai. Okay? So, as I said, my name is Luis Girigay. I'm based out of Miami in the US. I'm probably one of the people that Sanchit said, coming from very far. And been consulting, being in IT for a very long time. But what I do at AWS is that we lead an organization called AWS Solutions, where I focus on building products or solutions for infrastructure, compute, storage, networking, and edge, basically. Three topics we're going to discuss today: efficiency, reliability, and resiliency. I'm going to start with efficiency. If you go back to the stadium, we need to make sure that we don't go over budget. And what I mean by that is when you build technology, when you build products, you need to make sure that they do what they are supposed to do. They do it very well, but without wasting resources. That is efficiency. So, a basic example, an EC2 instance. If you're going to put some type of workload on an EC2 instance, and you can put 64 gigabytes, and it's going to work great, that's awesome. But if that solution, if that workload can do exactly the same with the same performance, the same latency, the same response time, by only using 16 gigabytes, that means that's now efficient, right? You don't have to oversize, you don't have to overpay. The next topic is resiliency. And this is where I want to combine resiliency and reliability a little bit. Most people think they are both the same. They are not. Yes, they are related, but they are not the same. Let me tell you why. Resiliency, it's all about recovering from a failure. Resiliency is all about providing a seamless experience after something bad happened. Could be a server crash, could be a data center crash, could be a whatever it is, right? But when there is an interruption of service, resiliency is the framework, the umbrella that helps you prepare to recover from that. Chaos engineering, for example, is what you do to make sure that you have a resilient system. You introduce chaos, you introduce failure into your system so you learn, so you know how to recover from that particular failure. Reliability is everything you can do, anything you can do to prevent a failure. So, why would you prepare? Let's go back to the stadium analogy. Would it be better to prepare to make sure that all your entry and exit points can support the amount of people that are going to go through those gates, rather than, oh, if we get at capacity, we have to go get a hammer and open another gate right away. You don't want to do that, right? So reliability is everything you can do to make sure that you don't have to worry about resiliency. At what point you can do all this testing? At any given time. Whether you are a developer, an architect, or someone that is participating at the different stages of the software lifecycle, you can implement these testing technologies at multiple phases. As a developer, you can do it during unit testing. As an integration developer, you can also do it during interface testing, make sure you connect through other systems, functional testing, all of that. But I want to focus on right here. Performance testing and chaos engineering is the one where, whether it's at the beginning or at the end, you make sure that two things need to happen. This particular unit, whether it's code, an application, or a particular flow, can recover from a crash or can support that particular load that's going to be coming to that. According to Gen AI, that's supposed to be me. Okay? So, maybe they put me an extra few pounds or kilograms. So, one of the most important things you have to do when you build reliable and efficient architectures is performance testing. So, just to make it simple, I'm going to call this guy Luis. So, you can see Luis is holding a car, or I'm holding a car, right? Yes, I'm very strong. But performance testing, what it helps you to understand is how your application, how your architecture will behave under different load conditions. So once again, performance testing is the ability to understand how applications, architectures, systems will behave under different load conditions. So in this case, yes, I'm holding a car. But for how long can I hold the car? What happens if I put a second car on top? What happens if I try to walk while holding the car? Can I even walk? Or if I walk, how fast can I walk by holding the car? So those are all different load conditions and different variables and scenarios that could happen to any given application. And by the way, most people don't even think about that. Yes, I'm holding the car, I'm very strong, but what happened when I put the car on the side? Would I stay alive? Will I be able to go back and be able to walk? Because I need to recover from that particular load. So again, very important question that you answer with performance testing. Most people that do performance testing, they do two things. One, they send an email to everybody, hey, go to this page and just hit refresh, and they ask like a bunch of friends and family and groups, like, do it. But that's not performance testing at scale. And the other thing that people do is that they do load testing from one machine, from like a JMeter or something like that, or from their own laptops, and then they try to simulate the traffic. That is also not proper performance testing. Because performance testing is the load, but also what you want to get out of it, the insights. For example, if you have an application with 1 million customers, you always want to do load testing, which is the basic type of test, so you know you're going to be able to support 1 million customers, right? Because I'm going to make an emphasis here in the word expected, okay? You know that's the user load you will have, so you will always have to be prepared for that. But what happens if you are running a promotion, you are running an event, and you just don't know how many people are going to show up? That's when you do stress testing. That could be 2x, 3x, 10x the amount of the expected load. So if it is 1 million, it could be 10 million. You decide the number, not me. You decide the number. But there are two things you want to understand or you want to get out of stress testing. Number one is performance degradation points. At what point my system is going to stop performing the way it's supposed to under a traditional load. And the other thing you want to get out of that is the breaking point. Yes, if you're using Kubernetes, auto-scaling, things like that, you can always auto-scale. But guess what? It's not unlimited forever. At some point, something's going to say, hey, even in Kubernetes, don't go beyond this number of nodes, something like that. So that's why you do stress testing, so you know the limitations of your system. So when your manager, your boss, your CEO says like, will I be able to support this launch? You will be able to say yes. Okay, endurance. Remember me holding the car? That was a picture. That picture took 2 seconds. 5 minutes, 1 hour, 7 hours. For how long can I hold that car? How many of you are Java developers? Okay, quite a few. So, if you do Java development, and other technologies have similar problems, but when you do Java development, and you are going to get a memory leak, that memory leak is not going to happen in the first 5 minutes. It's going to have, I see people laughing like, I have seen it. So, that memory leak will come after an extended period of runtime. So that's another test that you need to do. You need to understand how your system performs under a particular load for an extended period of time. So that is endurance testing, or also called soak testing. Scalability, pretty simple. Going to from point A to point B. How long is going to take? How my system is going to behave? How fast my system is going to auto-scale as I go through that increase in load. That's a very basic type of test. By the way, it's not one or the other. You can combine all these different scenarios into a single test, because it's all about your system, your application, the insights you want to get. So feel free to combine some of these. Very important. Number one, most people think about load testing or spike testing on the way up, but what about on the way down? For example, going back to the car analogy, I'm holding the car, I put it on the side, and I will probably walk like this for a week, right, because of the pain. So with spike testing, you can measure how your system will behave under sudden changes in load. And those sudden changes could be on the way up, because for example, if you're running a promotion at 9 a.m., at 8:55, you will probably have 100,000 people on the website. But at 8:59, you will have 17 million people refresh, waiting for that, add to cart or whatever button is to show up. So that will be a spike. You're going to go from 100,000 to 17 million in a minute. Can your system support that? If you are using something like Kubernetes, is your auto-scaling, your HPA configuration, scaling fast enough? Probably yes, probably no, I don't know. Those are the things you will get out of spike testing. Now, what about the other scenario? I ran the promotion from 9 to 10, I got 17 million people, at 10:01, promotion is gone. So what's gonna happen? It's gonna go from 17 million, boom, down to like a very low number. Most people would say, oh, my system is gonna release all the resources peacefully back into the cloud or back into my architecture. Yes, that's a fair assumption. But what happens if your system doesn't know how to do it? Or, very important, especially in cloud, what happens if your system is taking too long to release those resources back? You are literally paying for compute power or resources that at that point you don't need. So there are other strategies where you can accelerate that. And again, this is all based on metrics, based on real data, that once you do this, you will be able to, confidently say, this is what I know, and this is like everything that will happen to my system. And before you take that picture, the last one, volume testing. This is all about data. This is all about data ingestion, data retrieval, okay? Whether it's database, S3, files, you name it. Can my system support ingesting millions of transactions or downloading millions of files? I don't know. Volume testing could be part of load, could be part of stress, but remember, what I like to call it out as a separate test is because it's all about data. When should I do performance testing? I think that we all agree that in this room, everybody's in technology, and everybody's doing something with technology. So if you are in IT, and you are breathing, even if you are sleeping, but as long as you are alive, you should be doing performance testing. So early, after, and always. Whether it's an architectural change, whether it's that you are expecting a major event, or, like I said, even if you are sleeping, you should be running performance testing on a daily basis. Maybe not all of them, maybe just a traditional load test, because you want to understand what's your baseline. For example, you have this particular system. You know this is your baseline. Every day is within this range, right? So that means you have a healthy environment. But what happens if one night that number, that baseline, is now 20% or 35%? You define the number below that baseline. You know you have a problem. You need to go proactively and investigate because your baseline changed. But very important, what happens if you wake up one morning and that baseline is now 40% faster? You're like, you better be suspicious about it. Like, what happened? Most likely, it's not like out of the blue, like, it stopped raining and your system is going to be faster. It could be that there was an architectural change on the infrastructure side that you were not aware of, or could be, and it happens a lot, that some particular component in the application was supposed to do something, didn't do it, and that's why you see it's faster. No, it's not faster, it's just broken. It's just that you're not seeing the error yet. By the way, how many of you know about Graviton? Okay, very few. This is a problem that we need to solve. When I talk about compute efficiency, when you move a workload running on x86 to AWS Graviton, two things are going to happen. It's going to run faster, and it's going to be cheaper. Why? Because AWS Graviton is a chip from AWS based on ARM architecture, and by definition, and again, your outcome might change, but by definition, it runs faster and it's cheaper. So when I talk about infrastructure changes, do it. I don't have enough time to do a demo, but I'm going to be here all day. If you want to see a demo, I can show you real data, real metrics of one application, exactly the same application, running on x86 and running on Graviton. The one in Graviton runs 40% faster, and it's cheaper. And it's exactly the same code, exactly the same workload. So again, with performance testing, you can show that. You can prove it. I'm not going to go through here. I don't know how much time I have. Oh, I think I'm good. So, okay. So I'm not going to go through all these details, but we talk about efficiency. We talk about reliability, better user experiences, especially if you are in an industry where you have to compete with other vendors. If somebody comes to your system or your website and everything takes 7 seconds to load, oh, come on, that's going to take forever, right? So make sure that you do proper performance testing. You identify the bottlenecks. One thing that you will see during my demo, again, if you see me around, is that you can identify whether the bottleneck is the database, is the storage, is the web server, the code, the Lambda function, whatever it is, right? So make sure you understand how things work so you can always provide better experiences. Scalability, we talk about that, and cost optimization. I talk about Graviton, but I'm going to give you another example. You are building an application, right? And this particular application, I'm going to try with small, medium, large, extra large, just to keep it simple, right? I'm going to try with the small t-shirt size. Oh, the application is taking 3 seconds to respond. Okay, good. What do you want to do next? You go for medium. Okay, medium is now 2.5 seconds. Okay, great. Let me go large. Oh, 1 second, amazing. What's the next step? You go extra large. Oh, it's the same 1 second. Okay, let's now try double extra large. It's the same 1 second response time. So at that point, why do you want to go to an extra large or a double extra large configuration if you're getting exactly the same response time, exactly the same performance? So at that point, we're focusing on efficiency, cost optimization. Remember, meet the objective, make sure your application does what it's supposed to do with the least amount of resources being unutilized. Okay, let's go to the next phase, testing frameworks. There are multiple testing frameworks in the planet because you said like, Luis, I get it. I should do it. The next question is, how do I do it? Okay, great. There are multiple frameworks in the planet. I'm going to focus on 3. Why these 3? Because those are the ones that are the most popular. Those are the ones that have been around for a while. Actually, one is almost as, well, not as old as I am, but one has been around for longer. But these are the 3 that I would encourage everybody to go and start looking at, understanding, so you can do proper performance testing. First one, Apache JMeter. How many familiar with JMeter? Oh, there you go, quite a few, perfect. 1998, 1997, something like that. It's a framework that it's old, but it's stable, and it's very robust, it's very complete. In fact, I would say that today, most people still use it. I don't know, maybe 60% out there of people doing performance testing, they prefer JMeter. With JMeter, you can do not only HTTP, you can do TCP, SMTP, LDAP. I mean, so many protocols that you can actually test. So all the examples I'm giving you is about testing an application, but could be testing your LDAP server, could be testing your Mongo database, could be testing your gRPC protocol that is doing whatever it's supposed to be doing. So with JMeter, you can do all of that. JMeter is based on Java. When you write on a script, it's very unlikely you're going to write this script by hand. JMeter has really good tools that will basically help you write that script, like a browser recorder, and like with GenAI, you can come up with really good tests, but JMeter is kind of based on Java, and the script is going to be all YAML and XML. Next one, K6. How many familiar with K6? I see like one person in the back. Oh, actually quite a few. So, K6 is actually from Grafana. How many people know Grafana? Yeah, everybody. Awesome. So, Grafana created K6 in 2017, I believe. If you are a JavaScript developer, go nowhere else. Use K6. It's 100% JavaScript. You can write the code in your preferred platform, your preferred IDE, and it's all based on JavaScript. And just like JMeter, K6 offers plugins and libraries where you can test more than just HTTP. You can test a bunch of other protocols and frameworks. How many of you Python developers? Okay, perfect, quite a few. Last one, Locust. If you are a Python developer, go use Locust. It's all based on Python, just like the other ones, libraries, extended resources that will help you make your script very powerful and test a lot of things. Now, what do I use? I talk about three. Which one do I use? And this is kind of where AWS Solutions comes into place. You can use any of the three. I mean, if you are a JavaScript developer, use K6. If you like Java and XML, go and use JMeter. If you like Python, go and use Locust. No preference. But here is the challenge. For every single one, you have to spin up the infrastructure for that particular test, okay? For that particular environment. Whether it's K6 environment, JMeter environment, or a Locust environment, you will have to decide. Very often I see companies with different development teams. Oh, we use JMeter. Oh, this one uses K6. Oh, that one uses Locust. That's totally fine. That's totally fine. But the thing is that they are dealing with three separate environments. This is what I want to introduce, a solution from my team, something that I'm very passionate about. It's called distributed load testing. It's a solution, number one, 100% open source. Number two, 100% supported by AWS. If you have a problem with it, open a ticket, whether it's through AWS support, if you have access to it, or through the repo. We'll listen, we'll solve it, because we have a full team behind this particular solution. But the beauty of this solution is, number one, you don't have to spin up multiple environments. It's one single platform will support all frameworks. Number two, and this is a common mistake, if you have a global application or a global system, you want to make sure you understand the behavior of that application with traffic coming from all over the place. Because if that application is to be used by people in the US and Europe, you cannot do a test running out of your laptop 2 meters away from the server. That's not going to work. With our solution, the other thing we do, and by the way, let me say one more time, open source, no licensing. Feel free to use it, feel free to change it. If you are a business partner, feel free to sell it. We just don't care. What we really care is that people are building reliable and efficient architectures. With this solution, if you need to do a global test, this solution, once you decide the test, will go in real time to London region, Japan region, Mumbai region, US, Latin America, everywhere, and this solution will spin up all the infrastructure you need for that test. I want 1 million virtual users coming from London. I want 7 million coming from Japan. I want 100,000 coming from Brazil. Whatever combination, the solution will spin up the infrastructure for you. When the test completes, the solution is going to do something else. It's going to go back and it's going to clean up everything. So when the test is complete, you won't have a single CPU running. Today, most people doing performance testing have to manually deal with all of that. Not anymore. With our solution, we automate, we orchestrate, and we clean up. Remember? Cost optimization and efficiency. In our DNA, we recommend, it is in our DNA recommending our customers, do not spend more than you have to. So with that, I have like 8 seconds left. So my call to action for you guys is, number 1, go to the AWS Solutions Library. How many know the Solutions Library? Okay, perfect, quite a few, awesome. Go to this website right here, aws.amazon.com/solutions, and before you are about to build the next project, check it out. All of our solutions are open source. All of our solutions, if they don't do what you need to do, they are open source. Go take it. Maybe it does 50%. You can do the completion. You can like do the rest, right? And the other call to action is download distributed load testing, deploy it, use it, and like I said, it's okay if you don't remember my name anymore, but I want you guys to walk away with one thing. Be empowered, be confident that you can build bigger infrastructures, even bigger than the stadium here in Mumbai. Thank you very much, guys.